Good morning everyone, welcome in our next video lecture. In this lecture we are going to study about the transistors. One of the most important topic of the semiconductor devices. The transistors are the three terminal semiconductor devices. The first transistor, that is known as a point contact transistor, formed in the year 1947, whereas in the junction transistor there are the two types of the charge carriers, that is holes and electrons. So it is also known as a bipolar junction transistor. For the structure, a junction transistor consists of the two layers of one type of extensive semiconductor sandwiched between the two thick layers of other types of extensive semiconductor. There are two types of junction transistor, NPN transistor, and the second one is a PNP transistor. So now we are going to understand the first one, NPN transistor. In this, a thin layer of p-type semiconductor is sandwiched, or it is situated between two thick layer of n-type semiconductors, and the figure is also explaining it very well, that NPN, P is lies in between the two n-type semiconductor. The next one is a PNP transistor. So clearly observe from the figure, here n-type semiconductor is sandwiched between the two thick layer of p-type semiconductor, and the layer of the n-type must be thin and it lies in between the thick layers of p-type semiconductor. So the figures show the symbols that representing the PNP transistor. So now here are some terms that are used in transistor. Number one, emitter. Its symbol is capital E. The left side of a transistor, which is of moderate size but heavily doped. It supplies majority charge carriers for current flow through the transistor. Second one, that is the base. The middle region, which is lightly doped, and this is very thin, which is known as the base. The next one is the collector, that is on the right side of the transistor, which dopes slightly less than the emitter but thickness slightly more than that of the emitter. The collector gathers the majority charge carriers sent by the emitter. So the junction between emitter and the base is known as emitter base junction, while the junction between collector and the base is known as collector base junction. Now we are going to understand the action or the working of the transistors. The first one is the action of the NPN transistor. For this, the emitter base junction is forward biased and it is attached to the power supply, whereas the collector base junction is reverse biased and it is also connected to the power supply. To make a difference, let the power supply that is applied to the emitter base junction is denoted by VEE, and the power supply for the collector base junction is VCC. The voltage across emitter base junction is represented by VEB, and the voltage across collector base junction is represented by VCB. So this is a NPN transistor. When emitter base junction is forward biased, as we already studied, then the electrons that are the majority charge carriers in the emitters are repelled by the negative terminal of the power supply towards the base. So the barrier potential of the emitter base junction decreases and the electrons enter the base. So at the base there are the holes. So about 5% of these electrons combined with the holes in the base region, and they only form the smaller amount of the current, and that current we say as the base current, and the remaining electrons, that is about 95%, enter the collector region because they are attracted towards the positive terminal of the battery VCC. For each electron entering the positive terminal of the battery VCC, an electron from the negative terminal of the battery VEE enter the emitter region. So they form the continuous flow. So in this way there is a continuous flow of electron from emitter to collector through the base region, and this form the working of the NPN transistor. The emitter current is more than the collector current, and the base current is always the difference of both the currents, and it is proportional to the number of electron hole combination in the base. So now the next one, that is the action or the working of P and P transistor. The emitter base junction is forward biased, whereas the collector base junction is reverse biased. So this is the equivalent circuit that is shown in the figure. Here the emitter base junction is forward biased. So at the emitter there are the P type of semiconductors. So holes are the majority carriers in the emitter junction, and they are repelled by the positive terminal of the cell VEE towards the base and diffuse through the emitter base junction. So due to this, the barrier potential of the emitter base junction decreases and the holes enter the end region, that is in the base. A small number of holes, about 5%, combine with the electrons of the end region, resulting in establishing a small base current. The remaining holes, 95%, enter the collector region because they are attracted towards the negative terminal of the battery VCC. These holes make up the collector current, and the collector current is slightly less than the emitter current. As one hole reaches the collector, it is neutralized by the electron from the negative terminal of the battery. As soon as one electron and a hole get neutralized in the collector, a hole in the emitter is pushed towards the collector by the positive terminal of the cell VEE, and the continuous flow of holes from the emitter to collector through the base take place, and the emitter current is a combination of the base current and the collector current. Transistor is also known as a current controlled device. So now next is the amplifier, known as a common emitter amplifier, in which the transistor act as an amplifier. So what is amplifier? It is a device which increase the amplitude of the signal fed to it. For example, as shown in the figure, a weak input signal, that is a signal of a small amplitude, is fed to the amplifier, which in turn amplifies it, and we get output signal of large amplitude. A transistor emitter base junction, that is an input circuit, being forward biased, they have the low impedance, and the base junction, that is the output circuit, have been reversed biased and they have the high impedance. Moreover, almost all input emitter current flows in the collector circuit. Therefore, a transistor transfer the input signal current from low impedance circuit to the high impedance circuit. This fact is responsible for amplifying capacity of the transistor. So transistor act as an amplifier. So now we are going to understand the first amplifier circuit using NPN transistor. So the input signal that to be amplified is applied across the input circuit. Input circuit means the base emitter circuit. The input circuit is forward biased with the help of the battery. The amplified output signal is taken across the load resistance in the output circuit, that is across the collector emitter circuit. So the output circuit is reversed biased, and in this way we are going to amplify the input signal. If we use a Kirchhoff law, the emitter current is a combination of the base current plus collector current. So when collector current flow through the load resistance, then the collector voltage must be is equal to the applied voltage VCC minus voltage drop across RL. So if we see the figure or circuit diagram, during positive half cycle of input signal, the forward bias of emitter base junction increases. Due to increased forward bias, emitter current also increases. So if the emitter current increases, as the emitter current is a combination of the collector current and the base current, so hence collector current also increases. Therefore the voltage drop across RL also increases. So the collector voltage decreases because of this, since collector is connected to the positive terminal of the battery. So decrease in the voltage means that collector voltage become less positive, and in other words amplified negative signal is obtained across the output. So since in common emitter amplifier the output voltage decreases with increasing input signal and increase with decreasing input signal, so both the input and the output are out of phase. So in what the other words we can say that they have the phase difference of the 180, that is a 180 or pi phase difference between input and output signal. Now the next one is the amplifier circuit using PNP transistor. Here is a circuit diagram. So in this the input signal to be amplified is applied across the input circuit, and amplified output signal is applied across the output circuit that having the load resistance. Again the collector current plus base current is equal to the emitter current, and there is a voltage drop that is equal to the applied voltage minus of the voltage drop across RL. So during the positive half cycle of the input signal, the forward bias of emitter base junction decreases, and as a result of this emitter current and collector current also decreases. So there is a voltage drop across the RL. So in common emitter amplifier we see the output decreases with increases input signal and increases with decreases input signal. So in other words we can say that common emitter amplifier input and output signal are out of phase. There is a phase difference of 180 degree between the input and output signals. So now next, that important topic, logic gates. Logic gate is a digital circuit that is used to perform some logical operations, and there are the different types of the logic gates like OR gate, AND gate, NOT gate, NAND gate. First one is a AND gate. AND gate has two or more inputs with one output, such that the output is available only when all the inputs are available, which means that output is in a state 1 if all the inputs are in a state 1. Next one is a NOT gate. The NOT gate has only one input and the input is inverted to only one output, that we get the invert answer as the output. The next one is a NAND gate. This logic gate is that in which output of the AND gate is given to the input of the NOT gate, and the NAND gate is basically the combination of the NOT and AND gate. So thank you for watching this video. Hope these concepts are helpful and you get them very clearly. Take care.